Okay. Class is starting everyone. So who can tell me the answer for question 1 on the left page? When you have two numbers on the power, do you multiply them or do you add them? Multiply. Good job. Oops. So you keep our base, but you multiply. So what is 5 times 6? 30. And that's all you have to do. The next one, we have more thing on the base, but only one power. Distribute. Add to the 9, x to the 9.
Yes.
How about the next one? Same thing. 2 to the 7 divided by 3 to the 7.
Isn't it the same thing?
It's a 27 is to the.
No, they perhaps if we put 3 over 3 to the 7th power.
I gave you the same thing. So if you give me the same thing back. Come on, why it's not working? If you give me 2 over 3 to the 7, you give me the same thing what I give you. Right? I give it. No, the answer is 2 to the 7 divided by 3 to the 7. You always have to expand your powers. Roger. What for? Anytime you have one power but more things on the base, you always have to distribute your power. What? That's the answer. 5 to the power 17. So when you have same base, we keep the base, but we add the powers. So 17. Huh? Sure. Wonderful. Here we have denominator bigger. When we have denominator bigger, we keep our denominator. So denominator is t to the 8, and we subtract the numerator power. So it's 1 over 3 square. You can write 1 over 9, but you don't have to. Here, my goal is just to see your exponent rules. Okay, how about the last one? 9 to the power of 2. This time, our 8 is bigger on the numerator. So we keep our 8 power on the top and we subtract the 6 power from the denominator. So 9 to the power 2, 9 square. Roger. 9 over 2 over 1. 9 to the power 2 over 1. No, 2 over 1 is 2.
No.
Like 9 over 2.
9 to the power, right? 9 to the power 1 over 2.
No, 9 squared and then make a fraction, like let's put a 9 over 1 and then put the exponent next to the 2. I mean, next to the 9.
Why did you say not working today? 1 over this?
No. Then like this.
Oh, no, it's okay. Because this is and this is same thing. Come on, why my EDC is not working? Oh,
I still got it.
don't write the last part, okay? It's wrong. I just
The big hair.
I think it's.
This is really finding my element.
what's wrong with this? Come on. Okay, all of these are wrong, okay? This is the answer. No, for some reason the eraser is not working. So weird. Why not? No. Okay, any question on the left page? All of these are rules. Interesting things are coming on the right page. What is anything to the power 0 except 0 to the 0? 1. But what is 0 to the 0? Good. Only in this case, we have no idea what the number is. So anything to the power 0, a positive number, negative number, fraction, whole number, variable, anything to the power 0 is 1, except in one case, when you have double zeros. When you have 0 to the power 0, we have no idea. It doesn't exist. Another most generous one. What is 1 to the any power? 1. Now comes the discrimination. Remember my jokes? It likes it so much that it changes. And when it doesn't like, it just keeps as it is. What is negative 1 to the odd power? So it doesn't like odd power. So whatever we give any odd power, it stays same. Negative 1. But negative 1 loves the even powers. So what happens to the negative 1? It changes into a positive 1.
What did they?
That's it. Negative 1 with any even power is positive. Negative 1 with any odd power, still negative. And now comes the two scenario for 0. 0 to the any negative power. Undefined, it doesn't exist. What is 0 to the any non-zero or non-zero positive? Non-zero means it's not 0, and positive means only the positive numbers. 0 to the any non-zero, because when you have 0 to the 0, it doesn't exist. So 0 to the any positive power that is not 0 is 0. Okay. Guess what? You're going to see this again in your exam. So if you messed up today, no problem. Make sure you get them fixed before your exam. And your exam will be 2 weeks from today. Most likely. So study the review sheet very well. If you know everything in the review sheet, you're fine. My Microsoft Word is working very weird today. Okay, I lost everything. Never mind. Okay, so let's apply all these 0 and 1 rules to some questions. What is 1/2 to the power 0? 1. Remember, anything to the power 0 is 1, except 0 to the 0. How about B? -4 to the power 0. Anything to the power 0? 1. What is xy to the power 0? Still 1. What is x over z to the power 0? 1. Anything to the power 0 is 1, except for one case, 0 to the 0. And now we have a multiplication and an exponent. Handout says do what? Multiplication, exponent. So we keep our -9 and we do the exponent. What is x to the power 0? 1. And now -9 times 1? -9. Almost correct. You don't have to give me the number, just give me the rules.
Or you multiply that. So you have to use one.
So first you distribute, right? This power belongs to everything on the numerator and denominator. So you distribute U4 to everything. 3. Oh, this is why. Oh, no, it's working. Cool. 3y to the 5, -2 x cubed. All of them will get the power 4. Now 3 to the power 4. Is it 12? 3 to the 4 means 3 times 3 times 3 times 3. 3 times 3, 9. 9 times 3, 27. 27 times 3. Let's multiply. 3 times 7 is 21. 3 times 2 is 6. Plus that extra 2, 81. So this is 81. 2 powers together. Multiply. So we multiply y to the 20 and x to the 12. And now comes -2. We need to multiply -2 4 times. So if you have a -4 times, that turns into what? A positive or a negative? Positive. And then if you multiply 2 4 times, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16. That's it. We cannot simplify anymore, so this is our answer. That's -2 to the 4. We can actually rewrite as -1 times 2, right? -1 times 2 is -2. This thing has a 4th power. That means we have -1 4 times, and we have 2 4 times. So here comes the rule for negative power. -1 with the even power, 1 and 2 to the 4. So anytime you have a negative, even though you don't have a 1, no problem. You just see if you have negative even times what it becomes, other even. Sorry, plus or minus. Think about the next one. This is p to the 5, p squared, q to the 6, q to the 8. Exponent rules. We just did. In division, what do you do? We have two different variables, not same. One is p, one is q. So this p are same. These q's have the same base. So which p is bigger, top or bottom? That means you have to keep our p on the top. Which q is bigger, the top or the bottom? That means you have to keep our q on the bottom. Now, top p has 5 power. Bottom p has 2 power. When you combine, we get 3 power. Q, bottom q has 8, top q has 6. What happens? How many you have left? 2. In division, we always subtract the power. So it's p to the 5 plus 2 on the top and q to the 8 minus 6 on the bottom. Partially. Even if you have negative 2, you cannot leave it. You have to make it positive.
So, okay, so is this negative? Does
It-
it go up or does it go down?
So how are you getting the negative? Top minus bottom or bottom minus top?
Top, right,
So you're going to keep it on the top. But then since it's negative, you have to make it positive. So you have to move it on the bottom.
you would,
Top is wrong. It should be 5 minus.
Yes, minus. Sorry. Thank you. In division, we subtract the powers. So right now, I don't want you to work with negative because even if you know the negative power, it's useless. You have to make your negative power into positive power. And that's some other rules. That's why I don't want you to work with negative. Whatever is bigger, keep that on its position and subtract the other one. Okay, multiplication. Y to the 7, z to the 7. You're multiplying x to the 5, y squared, z cubed. So we have here y to the 7, oops, and z to the 7, right? And how about the next one? We have x to the 5, right? Y squared and z cubed. So you cannot distribute the way we distribute 2 times by 2 times. It's a multiplication. So in multiplication, you multiply everything. And then you collect like terms. So we see 2 y's, 2 z's, but there's only 1 x term. So leave our x term alone. We have nothing to do here. It's a single one. It did not get any partner.
I think the red, oh, wait, not just.
What happens to the y?
Why not?
And what happens to the z? So the final answer is x to the 5, y 9, z to the 10. Centigo. 7 plus 3 is 10, right? No. But I put them together so that you can see those are like terms. Huh? Alex or Alexis. I always get confused. Which one is Alex? The first one or the second one? Oh, he's Alex and you're Alexis. Okay. Alexis, question. Which part is confusing?
Why did it split them all?
Because I want to collect them and put them together. So if you put them together, you can see, oh, we have two y. So we add their powers. And if you put this together, we all two six. So we add the powers. You don't have to write this step. You can simply add their powers here. From this line, you can write this one. But I showed you the step. Quran, question? No. Ibrahima? Okay, who my question? They gave us a rectangle. And they said, well, let's say one side is 7x cubed and the other side is 9x to the 6 in feet. What's the area? So area of any rectangle is length times width. 7x to the third feet times 9x to the 6 feet, right? So what do we have? Aditya? 9 times 7 gives us 63. X square, so x cubed and x to the 6 gives us x to the 9. And how about feet times feet? Square feet. That's why area for anything has a unit square feet, square inches, square meter, square centimeter, all of these things. Because we multiply the two units. So if you want to write this down, with sentence, it's this square feet. This is too easy. It will not be in the exam, but it's in the homework. Any question? Okay, 10.2. Rational exponents means more rules. So make sure you put all the rules together or just copy them from the review sheet. Rational exponent, it means we have fraction in our power. So if you observe all the examples we did, all the rules we learned so far, they did not have any negative power or they did not have any fraction power. Here comes the fraction power. The job for fraction power is to make things smaller. When you have a power whole number, it makes things bigger. For example, if you have 4 square, it means 4 times 4, right? So the 4 becomes big to 16. But if you have square root of 4, what is square root of 4? 2. But why I'm saying square root of 4 when I'm talking about a fraction exponent? Jamil. Exactly. Because square root of 4 is actually 1 over 2 power. See, when we have 4 with a whole number power 2, it becomes big. But when you report to 1/2 power, 1/2 is a fraction, it becomes smaller. So fraction power makes things smaller, while the whole number power makes things bigger. What happened to my rules? Now I'm just saying, like, I thought I put together all the rules. Come on, I did not. Okay. Then let me write it here. If we have square root of x, it means x to the power 1/2. If you have cube root of x, it means x to the power 1/3. But if I give you 4th root of x, now what? X to the power 1/4. So whatever we have inside the radical, that goes to the denominator. Okay? So every radical is a fraction power, and every fraction power is a radical. So whatever is easier for you, you can write using that method. If it's the square root, if it's the square root makes it easier, keep your square root. Even if you see the 1/2 power, you can always convert them into radical. If you see cube roots, you can convert it to 1/3 power. Or if you're given 1/3 power and this is familiar to you, you can write them as a cube root. You can always write one form into another form. So general rule says it doesn't matter what number you have in your radical. It's always whatever you have inside, that to the power 1/whatever we have in the radical. Okay. So this thing is called index. And whatever we have inside, they have a name. We call them ready canned. So here our X is ready canned. All of these are ready canned. So we call them ready canned if you write them using radicals, or it's called base. It's called base if you write them using exponents. So here the name of this X is ready canned, but here the same as its name becomes base. So depending on where you are, like for example, at home, your name is your first name. In here, your name is your last name, usually. Okay. So same person you, but depending on where you are, you have two different names. So if you have something inside the radical, we call them radicand. But if you have the same thing with the power, we call them base. And if you have a number in the radical, we call them index. But if you write them with exponent, we call them exponent. They're the same thing, just two different names. Okay, now using all these rules, let's do some example. I mean, one rule with many forms.
That's supposed to have the number, because I remember the teacher telling me some, like the fraction, the bottom number is the root. So like the root of the 3, and then the top is like
True. Since you're mentioning this, let me give you one more rule. Or actually, let me give a page. So one more rule. If you have, let's say, nth root, but you have a power in your radicand, then it's same base, x to the m, but then the root goes on the denominator. So if you have a radical and a power at the same time, power is the strongest one, so it goes on the numerator. And radical equal the root. So root goes on the denominator. And like she mentioned, root goes on the bottom. When you have a tree, obviously the tree has root on the bottom, right? So whatever you have on the bottom is called root. In other words, it's radical. So root is on the bottom, exponent is on the top. Thank you for mentioning that, specially. It's a good idea. Root of all problems, math. So let's say have square root of x to the 3. How are you going to rewrite? X to the 3, and our root is 2. How about 5th root of let's say z to the power 7. Z to the 7 on the top, and our root is 5, so it's over 5. So these are new two roots. One is here, and the other one is here. Okay. Whenever you have a radical, you can convert this into power. And if we have a power and radical same time, radical goes on the bottom, power goes on the top. Okay. So 4 to the power 1/2. It looks weird, right? Well, we can convert this into square root of 4. And now it looks much familiar. What is square root of 4? 2. It's actually the word. It doesn't. So it's 64 to the 1/2. This is how it should be. So square root of 64. And what is square root of 64? 8. So the easy method is anytime you see 1/2 power, convert the square root. That will make your life easier. Convert, bless you. Convert 1/2 power into square root. Because you're too used to seeing square root. So if you see square root instead of 1/2, you know what to do. But for the rest, I would say don't convert, because there is another method of solving the other ones. This one says we have 64 to the power 1/3. It's cube root of 64, but we don't have to convert. Why not? Because our goal is to rewrite this 64 into one number to the power 3. Can you think of it? Which number to the power 3? 4. So let's rewrite this. Why? Because see, when you two powers together, you multiply them, right? But when you multiply, the numerator 3 and denominator 3 cancel out. So you left with only the base 4. That's why you don't have to rewrite. Because when you have a big number to work with, your goal is to rewrite that big number in terms of the root, the denominator, so that you can cancel the root. We hate roots. We hate denominators. So our goal is to rewrite your base in terms of the denominator. Well, let me rewrite. -9 to the 1/2 power. My question is, what is our base here? -9 or only 9? 9. What's the difference between this one and this one? See, because of the parentheses, our base here is -9. But we don't have a parenthesis for the first one. So our base is only the 9. If you don't have negative inside the parentheses, that negative is extra. So this thing is extra. Every extra thing we carry down And only 9 has the square root power. So square root of 9. That's -3. But if you had -9 with the square, with the 1/2 power, it's -9 inside the radical. Good, you remember. See, this time it's not -3. It says which number when you multiply 2 times, it becomes -9. It doesn't exist in real life. Okay? It does exist in the imaginary world, but not in the real life. So there is a difference between having a parenthesis and not having a parenthesis in your base. Okay, the next one, -81 to the 1/4 power. What is our base? -81 or only 81? So this negative is extra. That means we want to rewrite our 81. What number when you multiply 4 times turn into 81? 3. Good job. So what happens to the 4th power now? 4 power, 4 denominator, they fight with one another, they disappear. So we have negative here and 3 from the inside. -3. But if you're comfortable by converting them into radical, no problem. You can write 4/81 and then 3. But I found this method is actually much easier to see what's happening. Okay, and then here it says if you have double powers, it means power on the top, radical on the bottom. So if you have 8 to the power m, and then you're taking the nth radical, this is same as 8 to the power m on the top, n on the bottom. And you can also rewrite this as the radical first and the power. They all are same. All 3 of them are same. You can put either the power inside the root, or you can put the root inside the power. It doesn't make any difference. I mean, they do make some difference. It depends on the base. But all 3 formats represent the same thing. Should be M. It was just lying down. Okay, now, like I said before in the last example, if you have a negative inside your base, then you have some problem. So there are 2 rules. If you have a negative base, but your radical is an even radical, the answer doesn't exist in real life. But if you have a negative base, add radical, and the answer does exist. For even radical, we cannot have our base negative. That's the rule. Even radical cannot have negative base. even radical or root cannot have negative base. So if you have parentheses in the base, that means it's negative, the base is negative. But if you don't have a parentheses, that means if you have a negative, it's extra. For square root, it's easy to see. Square root of -4, like we said, we have no idea, so it doesn't exist in real life, okay? But it does exist in the imaginary worlds. We are going to learn that in chapter 7 or something. And this one, because our root is a 4th even number and our base is a negative, it doesn't exist. But for add, it doesn't matter. You just have to carry down your negative and you will be fine. Especially enough one. Ready? For the right page? We are going to simplify. So we have 64 and our power is 2/3. Our goal is to rewrite the 64. But we are looking for one number to the what power? 2 power or 3 power? 3, because our denominator is 3. So based on the denominator, we rewrite our base. 64 is what to the power 3? 4. So if you multiply 4 3 times, it becomes 64. We are rewriting 64 in terms of 4 cubed. And then what happens? Why did you rewrite? What is our goal? Cancel out the denominator. So what remains? 4 to the power 2. And what is 4 to the power 2? 16. That's how we simplify. And you'll have this in the final exam. Simplify one of these. In the next one, what is our base? -64 or only 64? Only 64. So this is extra. And our base is 64. Every extra thing we carry down, and we do the same thing here. We rewrite 64 as 4 cubed. So 3 cancel out. We have -4 with a square. So what is our answer this time? Negative 16. The next one has same thing, 3 root. Roger? It doesn't exist if the root is even number. If the denominator is even number. But our denominator is not even, it's odd. So when you have odd root, you can simply take your negative and never mind. So what number when you multiply 3 times becomes negative 64? Negative 4. So this becomes negative 4 with a power 3. And actually I should put double parentheses. So 3 power 3 denominator cancel out. What do we have this time? Negative 4 on the base, 2 power on the top. So what do we have this time? Negative 4 times negative 4 gives you positive 16. So if you don't have a negative in the parentheses, all you have to do is carry down your negative sign. But if you have it inside the parentheses, you're going to work with that because your base is negative this time. Okay, you try this. You just have to observe what type of radical you have. Oh, I forgot the attendance. Roger, question?
Yes, so the third one, right? You said that it's only for odd hours.
If you have a denominator odd, you can simplify. But if you have a denominator even, then you cannot simplify, it doesn't exist. If your base is negative. Helen here, Daniela here, Alexis here, Sophia here, Evelyn here, Catherine Chen here, Sharon here, Kevin here, Emma here, Horan here, Kira here, Ibrahima here, Gianni here, Alex here, Jonathan here, Freshly here, Shinea, absent. Nicholas, absent. Zachariah here, Jean here, Roger here, Catherine Lynn here. Jaylene here. Yariel here. Ashley. I always get mix up you three. So Evelyn, Ashley, Vianney. Evelyn. Brenda not here. Juliana not here. Vianney here. Niley here. Brittany here. Aditya here. Jade here. Jamil here. Santiago here. Jayla. Absent. Skylar here. Seeing here. 1, 2, 3, 4, 5. 5 absent. Okay, are you guys done? You can try the next one. And what did I have more? Yeah, so let me put them together. Give me 1 second. Okay, these 5. Yeah, no problem.
Like, I don't know if it's like,
Which number to the part 5?
I don't think that's.
That is 2. You multiply 3 times. You get 3. Now then try 3. It's just like getting. He cannot write. He cannot read. He can point everything. Girl, that is not easy part. Wow. What do you think this week? What a baby. Please identify these are into our down questions. You need to remember. Girl, shut up. You need to relax. Time's that. Girl. Like, yeah, okay. I thought you were sure. No,
Okay, I'm gonna cook.
Yes.
No question. The right answer.
So.
So it's I'm putting it out. I think.
And you didn't catch it. You didn't catch it.
Are you sure?
Yeah, you did hold on. The same thing he asked is.
Oh, if it was like that, I would get.
My question is, from here to here.
Remember the situation.
So do the same thing for this one. One to the power. One. So if the one over right, so it's one over. So one over one.
Oh,
That's the same. This one. You didn't use first, that's the whole reason. I tried so hard on the microphones. Well, I'm about to go. I do this one. I didn't know we scored good. Valerie,
They're going first.
It's a phone call, but they will be the whole.
There's so many.
Now, bar.
Okay, you
Yeah.
I just don't. Like, what are they gonna do?
One of us.
So now actually.
And it shows you one of them.
So what is, would they ever give you a score?
I bought my good. I bought my
job. I'm really about to-
No, listen. Drop it.
Negative 2 square is not negative. Negative 2 square is positive.
That's why.
Negative is not negative.
So. I'm gonna, I started remember.
Yes,
Where does it work?
What does she give us in the problem?
And then at the end.
I used to work on like I would love something for yeah, I just a Friday place like I love we're gonna have to go to working. I'm definitely gonna take my. Tell me how I was right. You what? How? I'm a gibberish. But how? I have no idea. I don't even know how that works.
You get one.
But listen. Thank you, Max. No, this. Five. Wait, let me see. No kidding.
Yeah.
You did it wrong. Yeah.
Well, I didn't really. I just mostly don't go. I just go.
I put three.
Yeah. Oh, yeah.
Okay, wait, where? And you don't like bake that. Maybe it's a big. If you mention my yeah.
The phone number is. Yeah.
No, wasn't this. No, like actually, like on a person, but I can use the number. In the butt. I gotta get some. We haven't even done it. Yeah. I'm very excited. Writing it down. Today. I think it's probably the first for well, let's say, like, you feel, like, you have to, like, and I always figure out. She was. What do you want? Maybe just.
Yeah, we just have like two exponents.
Oh, for what? No, because.
Okay, so we keep our 4, so we keep our power and we rewrite the 4. How do we rewrite the 4? With some power. 2 to the second power. And then what happens? The 2 power, 2 denominator hate one another, they cancel out. So it's 8. For the next one, this is extra. For extra thing, we just carry it down and we do the same thing. So our 4 is again 2 square. They cancel out. We still have our extra thing. So this time it's -8. For the next one, many of you got it wrong. That's what I said. Anytime you have the even root, you can actually rewrite this way. Or square root of -4. Either one is fine. Why I'm rewriting? Because you can see square root of a negative number. We don't know what is square root of a negative number, not yet. To show you why it doesn't exist. You don't have to rewrite.
Yeah, I mean, when you look at as an example, it has a positive denominator. So it's gonna be with the negative, no, it's gonna be the odd.
See here,
I know the odd.
when you have a negative base, but add denominator exist. Because we can rewrite. But for this one, we cannot rewrite the -4 in terms of 2 power. So here rewriting is impossible. No number square will give you -4. So it doesn't exist. For the next one, anytime you see big number, always start with 2. See what is 2 to the 5. Then what is 3 to the 5? What is 4 to the 5? The answer will be always from all those 2, 3, or 4. And really it will be from 5 or 6. So we are looking for one number to the 5 power. What number to the 5 power is 243? 3. So 5 cancel out. We get 3 to the 4. And what is 3 to the 4? 81. The next one, because you see a fraction, You got scared. Well, no problem. Remember, bless you. Remember the exponent rules. If you have more thing on the base, it distributes. So you can actually distribute the power. So you get 1 to the power 3/4 and 256 to the power 3/4. But we learned that 1 is very generous. It doesn't care about its power. 1 to the anything is 1. Okay. And now rewrite 256. What you're looking for? One number to the what power? So what to the 4 give you 256? Is it 2 to the 4, 3 to the 4, or 4 to the 4? 4 to the 4. So 4 cancel out. We still have 1. And then for Q, that's how we have 1/64. And now comes negative power. But before that, let me show you the rule. If you have x to the -1, every negative power turns into a fraction. That's 1/x to the +1. In other words, it's simply 1/x. Can you guess how you're going to rewrite the negative power for 2? Alex? 1/x to the power +2. So anytime we see negative power, we don't like it. You must convert the negative into positive. All you have to do is switch them. Switch the position. How about, let's say you have 3 to the power 4. What is this? 1/3 to the power +4. And what is 3 to the 4? 81. So negative power means it's a fraction. So the general rule is x to the any power, it doesn't matter what power it is, it's 1/x to the positive power. Following this, let's see the fraction x/y to the power negative. Can you guess what it will be? How can we convert this negative n power into positive n power? Jean? 2. All you need to do is flip your fraction. It becomes y/x, and the negative power will turn into a positive one. It's a trick. If you flip your fraction, the negative will turn into positive. And let's say have x to the -n/y to the -n. Both of them have negative powers, but we don't want them to have negative powers. How can you convert them into positive powers? Flip them. This bring down on the denominator, it will become positive n. This bring up, it will have positive power. So anytime you have a negative power, all you have to do is change its position. If it's in the numerator, put it in the denominator. That's why all these, they're on the numerator. When you make it a fraction, that goes in the denominator, the power turns into positive. So for our next quiz, I'm going to give you the rules. So let's put together all the rules we learned today. First rule, what did you learn? Radical, right? Rules for next quiz. If you have x to the 1/2, it means square root of x. Following these rules, the general rule is x to the 1/n is nth root of x. Then if you have nth root of x, but this x already has some power, it will be x to the power on the top, the root goes on the bottom. Did you learn any other exponent rules? No. Then comes the negative rules. X to the negative n is 1/x to the positive n. X over y to the negative n means y over x to the positive n. And if you have double negative, all you have to do is reverse, flip them. I put an arrow because this is this, x to the negative n, y to the negative n. So flip them as you can whatever. So these are the rules I'm going to ask you in the next quiz, along with the rules you did today. The quiz you took today, you're going to do the same quiz again in next class with different numbers and variables, plus the new rules. Okay? So in the next class, rules again, all the exponent rules. And remember, your first exam is 2 weeks from today, October 1st. The quizzes and homework, they all are done by Math Lab, 15 or 16.
What can you do? You said October 1st? Yeah.
Which is 2 weeks from today. Two.
And 6, and then the quiz that.
So when your code is coming,
I still the guy. Yes.
okay,
So I'm not sure.
you'll be fine. So goodbye, everyone. See you again on Thursday.
So I'm gonna buy.